Hello everyone. We are going to continue our story about object first pipelines. And I would like to first finish what we talked about in class about the camera matrix. So we made a lot of progress, but we weren't quite finished. So just to review, what's happening every time we try to figure out a final position of a vertex in the vertex buffer is we take the position in object coordinates. We first multiply it by some matrix that brings it into world coordinates. So that's determined by the seam tree. So that you already have seen. This is the one we're working on now. This is the camera matrix. So once we have brought it into world coordinates, we then need to transform it into coordinates where the camera is the origin. And finally, we're going to project, and that's the next thing we'll talk about. So we got to the stage where we were filling in a 4x4 matrix that was going to represent this camera matrix. And we remembered that it was specified in column major order, so the indices actually go along the columns first. And we did this thing where we said, okay, let's make indices 12, 13, and 14 be the negative I, so the negative center of the camera, since you saw that if the camera is moving to the right, the whole world should move to the left, and vice versa. Then we did something similar with the rotation. So we set up a rotation part in the upper 3x3 part of this matrix. And we said, well, we tried putting the right vector along the first column, the up vector along the second column, and the towards vector along the third column. What we found was that that moved us with the rotation. So we actually want to move against the rotation. So if we rotate to the left, the whole world should rotate to the right. And what that means is we actually need to put these vectors along the rows. So the right vector goes along the first row, the up vector goes along the second row, and the towards vector goes along the third row of the upper left 3x3 part of this matrix. So the right vector is going to go 0, 4, 8, the up vector is going to go 1, 5, 9, and the towards vector is going to go 2, 6, 10. And the reason for that is the inverse of any rotation matrix is its transpose. So just changing the rows for the columns. That will undo whatever rotation was in the original matrix. Okay, so we're trying to do the inverse. We're trying to go the opposite of how the camera would rotate. We're trying to rotate the world the opposite way. Okay, so we're making pretty good progress. But what we saw was, okay, I can still move around just fine. Like the translation part's working, but the rotation part was a little bit different than what we were expecting. So it seems like no matter where we are, the center of rotation is the center of the seam. Hang on, let me reset here and we can look again. But see, no matter where I am, the center of rotation is the center of the scene. And that's not what we want. We would like to, this is not how a person would move if they were moving their head, right? They don't suddenly rotate around this whole thing, around the center. So we have to be a little bit careful with how we specify. Actually, what we need to do first is translate the world and then rotate. So right now we're doing a rotation followed by a translation. That's what happens whenever you put these in the same matrix. It'll do the upper 3x3 part and then add the vector as an offset. But we actually want to make two separate matrices and do them in a different order. So what I'll do is I'll call this T matrix. This will be my translation matrix. And I'm also going to make a R matrix. So I'll say let R matrix equals GL matrix.mat4.create. And this is a totally separate matrix here. Okay, and I want to do the translation before I do the rotation. So what I'll do is I'll make a new matrix. And I'll say GL matrix.mat4.mul, multiply. So the result will be stored in M. And I want to do the translation first, so that means that the translation will be on the right. So I put R matrix and then T matrix. So translation will happen first, then followed by rotation. Okay, now I can return the final matrix. So let's see if that worked. Okay, beautiful. So here we are. So now I'm moving like I expect. So I'm heading towards Homer's head, heading towards the dinosaur. Now this is more how a person would move if a person could sort of float and move around left to right arbitrarily. All right, so that was it. We were very close in class. I just wanted to finish the story by saying you have to translate the world first. So move the world so that you're at the center. We're very self-centered here, okay? We want to move the world so that it's centered on us. And so to do that, we subtract off the I. That's another way to look at it. We're making us the origin. So we're subtracting off the I from everything. Once we've made us the origin, so T matrix happens first, then we rotate the whole world around us. Okay, so I'm the origin now and I can rotate. So that's how the camera matrix works. And that's all there is to it. Okay. So now we're going to move on to talking about projection matrices. So take a deep breath and hit next and we'll go on to that.